So I only have two stories, and what we're going to do is we're going to start out far in the universe, talking about other galaxies, and then we will slowly make our way back to our own galaxy. But I want to talk about what are called active galaxies first. And active galaxies are galaxies that, well, as the name suggests, they have activity. But what do we mean by activity? Well, we believe that most galaxies, or most large galaxies, have black holes at their centers. So, at the center of our galaxy and at the centers of most elliptical, large elliptical, and spiral galaxies, these are all spiral galaxies. They have black holes. And active galaxies are galaxies where the black holes are actively pulling in gas, or there's enough gas that in the center or near the center of the galaxy for that some of the gas to fall in, and not all the gas falls into the black hole. A lot of it gets jammed up, and as a result, a lot of it gets spit out as well. And so these galaxies have what a lot of astronomers call central engines that are powered by these black holes that radiate out lots of energy, electromagnetic radiation, as well as you can often see jets of gas coming from them as well. And you might have heard of quasars. Quasars are very distant versions of these active galaxies, and they're so distant that for many decades astronomers didn't really know what they were because they couldn't actually see the gas and the stars around that central engine, because galaxies are made up of stars and gas, and those are easy to see for nearby galaxies. But for distant active galaxies, you could only see that very central part that's extremely bright, that varies quite a bit, meaning it can grow much brighter and dim again on very short time scales. And that's all related to the fact that there is this central black hole at the center. And when we look out into our universe today, up to actually at least 10% of the nearby galaxies have some form of activity. So we know that there's stuff going on, meaning there's gas falling into that black hole. Some of it is getting jammed up, and it gets forced out into out of the galaxy again. So all these galaxies, even though they look like spiral galaxies, our Milky Way is what's known as a barred spiral, but they all show some form of activity, some form of variability. And you can even see that some of these have this reddish stuff. This is images that were taken at multiple wavelengths, and this actually shows gas that has been disrupted and has been flung out from these galaxies. Now, one thing that astronomers have realized over the last several decades is that galaxies are not static, but they merge and they have interactions with other galaxies. So even though the universe is expanding, galaxies are large enough that it is relatively easy for them to get close enough and gravitationally interact. And so this is a series of computer simulations where we're looking at two galaxies that are spiral galaxies, like the Milky Way, and one is about twice the size of the other. And here we're seeing just the gas. And what has happened is that in that first pass, a lot of the gas gets driven by the gravitational interactions between the two galaxies, and that gas falls into the central black holes of the two galaxies. And that causes an initial wave of activity from those black holes, and you might get some jets and some energy being radiated out. But then what happens is over time, the two galaxies actually merge, and the two black holes also merge, and the luminosity of the final merged black hole increases to such an extent that it manages to blow out all the gas that was piled up at the center. And right now we're seeing the stars, but we'll see the gas and the stars again. And notice that this is a counter at the top that shows the time passed, and it's on the order of about 2 billion years. So that's how long these simulations can last. But so here's that first passage, and you're getting a lot of gas driven into the black hole. So we have gas on the left-hand side and the stars on the right-hand side. And you see that some of the gas and the structure of the gas and the stars do sort of mimic, but as the two galaxies merge, the gas will get really disrupted. So here they're starting to merge, and you can see just these outflows of gas getting propelled out. And so this is what is happening as the black holes merge. And there's just so much energy that it drives out all of this gas. And there's just waves and waves of outflows of gas from the center of the galaxy. And what's amazing about this is that we can run computer simulations where we have galaxies in our computer with certain amounts of gas and stars and certain mass black holes and dark matter and a lot of physics, but we can go out and observe galaxies in different stages of interactions and see that a lot of what we see in the simulations actually shows up in real life. And so this is one way in which we can test our knowledge, because obviously we can't live for 2 billion years to watch galaxies interact. We can instead look at lots of galaxies and find examples of galaxies at different stages of these interactions and then compare them to our computer simulations. All right, so one really weird object that was found by astronomers about 5 years ago is something known as Hani's Vorwerp. And this came out of a project where citizen scientists, basically volunteers, could sign on and look through galaxies that were found in a catalog called the Sloan Digital Sky Survey. And a woman named Hani, and I can't remember her last name, but she's Dutch. And so Vorwerp is a Dutch word meaning object or thing. And so this thing that she found is now known as Hani's thing. But it seems to be related to this galaxy, IC2497. And the reason why it shows up as green here is that this is actually a Hubble Space Telescope image that was taken sometime after the initial discovery. And they were looking at a emission from oxygen atoms. And so that particular line of oxygen is in the green, so that's why this shows up as green. But this was a very mysterious object because it does seem to be associated with this galaxy, but this galaxy is not active in the sense that it's not on right now. There doesn't seem to be gas falling into the central black hole. And so there was some speculation that perhaps that this thing, which is tens of thousands of light years away from the galaxy, was the product of one of those close interactions that we saw in the animation. Although this was perhaps a galaxy that swung somewhat close to this galaxy, but not close enough for it to start merging like we saw just a few minutes ago. But it left behind some amount of gas, and when the central black hole engine was active, this gas was illuminated by the light, the UV light from the central black hole, and it caused the gas to glow. But since then, the black hole engine is shut off because it used up all of the gas, and so we don't see any activity from the central black hole engine. But because this clumps of gas is literally tens of thousands of light years away, it has taken that long for that light to reach here and to interact with that gas clump. So this was really interesting, but because this was the first of this type of object, astronomers can come up with possible explanations, but we don't feel like we have a good understanding of this phenomenon just based on one example. And as a result, astronomers went and actually solicited more citizen scientists who were part of the Sloan Digital Sky Survey project to comb through literally hundreds of thousands of images that were collected by these robotic telescopes, and to try and find more examples of this. And so in a paper, actually the Hannes Verwerp was actually found in 2007, but this paper that came out 4 years ago in 2011, they were able to find about 20 different objects. And so you can see, and in this case, instead of being green, they color these. These were all colored in the computer. These were all colored blue. But what you sort of see is that these galaxies, or many of them, seem to be caught in the middle of an interaction with another galaxy. So you see in tidal tails. Here you can actually see two galaxy cores. Here again are two galaxies that are somewhat separated, but there seems to be stars that bridge the two galaxies. So there's the sense that there are interactions going on when you examine these closely. And now these are all images taken from the ground, and so in order to really get a good idea of what is going on, you have to go to the Hubble Space Telescope and go into space. And so the author of this particular paper did that, and this was a paper that was just announced where they were looking at 8 of these galaxies, and here they are. And so, these 4 and the next 4 that you'll see are ones that were in that original sample of 20. And so now the color coding is, again, they switched it back so that the oxygen shows up as green, but the glow, the orangish and whitish glow, is from the stars of the galaxy. And so the stars don't emit very much in this oxygen line. So you can see that these weird clumps do surround these galaxies, and they can actually be relatively far away, very similar to Hannes Verwerp, anywhere from 30 to 120, 150,000 light years from the centers of these galaxies. And this one is relatively close by, enough that you can see a lot of detail, but this structure, this gas structure, stretches out about 120,000 light years from the center out to the very edge. So these are extremely stretched out features. And then this one, you can sort of get the sense that the gas is being spit out in sort of a cone shape. And that is sort of consistent to what you would expect if they were being illuminated by that central black hole engine, because the black hole was surrounded by a lot of gas, and so the light and radiation from the accretion disk around that black hole tends to go out in the polar directions, and it's not a lot of these active galaxies, the emission isn't along a very tight beam, but it's actually extended into a cone. And so this is consistent with that cone idea. And if you look at a lot of these, there's a lot of symmetry. You can see that the spiral pattern is sort of replicated on the other side as well. And those symmetries, as well as a lot of these other patterns, are also consistent with the interactions that people see when they run computer simulations of colliding or merging galaxies. And this one and this one, the sort of shapes are consistent with what would happen if the galaxies, if the merging galaxies had actually merged and the two black holes had combined, so that now you're getting these huge waves of gas blowing out from the center of the combined galaxy, like we were seeing at the end of the animation. And so this is evidence for that what we were seeing in the simulation. And so in all these cases, these galaxies are not active currently. Based on sort of the statistical study of what we're seeing in these 8 different cases, what the authors of this paper are interpreting is that the phases in which the galaxy is actually bright, meaning there's activity around that central black hole engine, can last no more than, it can actually be relatively short, meaning they last only about 20 to 200,000 years, and then it switches off. And during that time, that the photoionizing radiation can travel out and illuminate these distant clumps of gas. And then once they're illuminated, we can see them, but by the time they're illuminated, the central engines have shut off, and so we don't see any activity anymore. So it seems like when Hannes Vorwerp was first discovered, it was a very mysterious object, but now that we're finding more and more examples of things like that, we seem to are getting a good grasp of what's causing this particular type of phenomenon.